Hello, I'm Walt Lovett. Welcome to my presentation on decision trees, specifically a classification rule. This is by no means a comprehensive Python tutorial, just a part, as I will focus more on the tree, the decision tree, than the code itself. Decision trees can be very simple. They help us predict outcomes given specific criteria. Those of you who have cats will get this immediately. My wife and I often referred to getting our kids to do something was akin to herding cats. This tree is a little more complex, and it could be useful to safeguard you against rainy weather, whether you bring an umbrella or wear a rain jacket or just stay home because it's just too bad. Other decision trees can be more complex. However, it's important to note that they don't always predict outcomes correctly. Again, another even more complex decision tree. I have to admit, the first time I saw a decision tree, I thought of a pedigree chart. It is a decision tree of sorts, I guess, only it's reversed and we see into the past instead of what may happen. All of those people decided to have children, and all of those people decided to have children, and eventually it gets back down to you. A decision tree is a flowchart-like structure in which each internal node represents a test on an attribute, for example, whether a coin flip comes up heads or tails. Each branch represents the outcome of the test, and each node represents a class label, which is a decision taken by the computer after figuring all the attributes. The paths from root to end node or leaf represent classification rules. This is a simple coin flip decision tree of all 16 possible outcomes of only 4 coin flips. H stands for heads and T stands for tails. And so each one would take a different branch, whether regarding which popped up as whether it would be heads or tails. So let's see a real world example here. The first one is tails, then heads, and finally heads. So we had tails, heads, 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 and putting it back onto that other decision tree, there it is, tails, then tails and heads, then tails, heads, heads, and then tails, heads, heads, heads. That would be the classification rule, if you will, of those 4 coin tosses. Now here's a simple decision tree that the Python code will complete. It's a classifier to assign a label, whether it be grape, lemon, apple, or banana, to a fruit based on its size and colors. Notice that we have 3 different colors for apples. Here you'll see the parameters of our training data for the program. We'll tell the program the color and size of the fruit, and it will use this tree to decide what fruit it is. First, it checks whether the fruit is a 4 or greater. If it is, it has to be a banana, as there are no other size 4 fruits. If not, it checks if the fruit is a 3 or greater. If it's not 3 or greater, then it must be a grape, because those are the only fruits that are less than size 3. However, if it is 3 and if it is size 3 or greater, then the computer needs to ask if the color is yellow. If the color is not yellow, then it must be an apple, as it is the only fruit that is size 3 and is not yellow. However, if the color is yellow and we're still in the size 3 size, then there's a 50-50 chance that it's either a lemon or an apple. So the computer really can't figure out those two, but it will give you that information. Let's look at an example of this program running in my terminal on my computer. It's pretty quick. So here we type it out, hit enter, and there's the code. If you notice at the top, it asks, is it size 4? And then the first arrow there says true, then you have to predict banana. If it says false, if it is false, if it's smaller than 4, then it says, is it size 3 or greater? If it is it yellow? And if it's true and it's size 3 in yellow, then that means it's a 50-50 chance whether it's going to be an apple or a lemon. If it's not yellow, then it has to be either green or red, so then it's an apple. However, if it is, going back to the size 3 question, is it size 3 and that answer is false, then it has to be a grape because, like we said before. So down at the bottom you can see where it starts with the word actual. We shot at a green 3 and it predicted an apple, a yellow 3 and it didn't know whether it was a lemon or an apple, a red 3 predicted apple, red 1 predicted grape, a yellow 1, and remember the numbers there are the sizes. A yellow 3, again, it predicted a lemon or an apple, and then a yellow 4, it predicted a banana. Okay, so up here in the upper right, again, we have the training data that we had that we mentioned earlier. The red 1 is a grape, yellow 3 lemon, red 3 is an apple. Okay, so the training data is the same. And we have on the right hand down at the bottom of the screen the output there. So let's say that we think, a banana, even though it's longer than an apple and a lemon, it's really not that much bigger. So we're going to change it to a 3. And down at the bottom where we send the information to the program, we're going to change it to a 3 and we're going to tell it that, yeah, this is a yellow 3. And we'll save that and run it again. And if you notice what happened there, it still predicted we sent it a green 3 and it predicted the apple again, but this time when we sent the yellow 3, it's also going to predict that banana. So instead of it being a 50-50 chance between an apple and a lemon, it's also now another chance of being an equal chance of being a banana, so then it becomes a third chance, or 33.333. So in the training data, let's say, the lemon is really a little bit smaller than the apple and the banana. And so let's change that to a 2 instead of a 3. And we'll change this to a 2 and save it. And run the program again. And now we can see that the yellow 2 predicted lemon 100%. When we get down to the yellow 3, it's now predicting a 50-50 chance between the apple and the banana, because there is a such thing as a yellow apple. We can see it right here. That's a size 3. Okay, so if we then say, I changed my mind, I think we should classify bananas as a little bit bigger because we went and weighed them and they're a little larger. So we'll change that to a 4. And change that, what we're sending it as a 4. Save it. Let's get a little bit of space here. And run it. And it can now predict with 100% accuracy those different labels. A green 3 still produces the apple. A yellow 2 now produces a lemon. Red 3 produces an apple. Red 1 produces a grape. Yellow 3 is only an apple because we have now a yellow 2, which is a lemon, and a yellow 4, which is a banana. And with that, we've come to the end of my presentation on decision trees. Thank you so much for watching.